give one advantage and one disadvantage of using box and whisker plot to represent a set of data. Advantage could be we can quickly find out the median or the upper quartile or the lower quartile or the interquartile range. And disadvantage could be that since we don't have the original data values, so we cannot calculate something like the mean or standard deviation. Okay. Part 2. Another group of 33 people ran the same marathon and their times in minutes were as follows. Part A. On the grid below, draw a box and whisker plot to illustrate the time for these 33 people. Okay, so in box and whisker plot, we need the smallest data value, then the lower quartile, then the median, then the upper quartile, and then finally the highest data value. So lowest data value is 190, highest data value is 375. Let's find the median and then the upper quartile and the lower quartile. Okay, so since these are 33 people, so we have 33 data entries. That means the middle value would be a single value. So to find that, we do 33 plus 1, which is 34, divided by 2, which is 17. So we're looking for the 17th value after arranging the data in ascending order, and thankfully this data is already in ascending order. 17th value would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 280 would be the median. Next, we need the lower and upper quartile. For that, we will look at the lower data values. This is the lower set. These are 16 values. So the value in the middle would be 16 plus 1 divided by 2, which is 8.5. So 8.5 means we have to look at the 8th value and the 9th value. We'll be taking average of the 8th value and the 9th value. So 3, 4, 5, 6, 7, 8. This is the 8th value. This is the 9th value. So what's the average of 254 and 258? That's going to be 256. So the lower quartile is 256. This would be 256. And similarly, upper quartile would be, you look at the 8th and 9th value in the starting from the end. So 1, 2, 3, 4, 5, 6, 7th, 8th, and 9th value. I need the average of 327 plus 331 divided by 2, that's 329. So the upper quartile is 329. Now we're going to properly plot these on the grid given. So we first need to select a scale. We need to go from 190 to 375. So we could start with 180. This would be 180. Then can we have 10 units division? I believe not. We'll need to choose an appropriate scale. So after 180, we could write 200 or 20 unit shift, then to 20, then to 40, and so on. Okay, so I've filled it completely, and remember to label the x-axis, which is time in minutes. So write time in minutes. Okay, so the lowest data value is 190. 190 would be exactly in between 180 and 200. So we could make a small line here, or even a dot would work. Then we need to plot 256. So that's 220, 240. 256 would be, this would be 250. And then 6 units ahead, So what is one small box equals to? One small box here, these are total 120 units from 180 to 200, and they are being divided into five parts. So 20 divided by 5 is 4. So this one tiny small box is 4 units. So if this is 150, then another box would be another half a box would be 2, and then another full box would be another 4, so that's 6. So 156 is exactly here, or one box before 160, sorry, 260. Okay, so I'm going to make a line here. This has to be bigger. Okay, so that is 256. Next is 280. 280 is simply this line right here. Next is 329. So 320, and then 324, then 328, and then slightly more than that, so like this. Next, last point is 375. So this is 360. Exactly in between would be 370. And we need to go another 5 units beyond that. So 2 and 4, slightly before this line. And this has to be smaller in size. So these are 4 units and slightly ahead of that. Okay, this would be the box and whisker. Part B, find the interquartile range of these times. So that's easy. Upper quartile minus lower quartile, 329 minus 256. 329 minus 256, which gives us a 73. In a survey, 55 students were asked to record to the nearest kilometer the total number of kilometers they traveled to school in a particular week. The results are shown below. On the grid, draw a box and whisker plot to illustrate the data. Again, for box and whisker plot, we need the lowest data value, then the lower quartile, then the median, then the upper quartile, and then the highest data value. And we plot them all according to the scale on the given grid. Okay, so in the question, the lowest data value is 5. The highest data value is 70. Now we need the median, lower quartile, upper quartile. Median would be the middle value after it's arranged in ascending order, and it's already arranged in ascending order. So there are total 55 data values. To get to the middle, we'll do 55 plus 1 divided by 2, which gives us 28. So we're going to mark the 28th value, which will be the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This will be 22. So 23, 24, 25, 26, 27, 28. This is going to be the median, which is 25. So we'll mark 25 here. Now we need the lower quartile and the upper quartile. For lower quartile, what do? We look at this lower part of the data, excluding the median. Now, how many data values are these? 25 was the 28th value. So subtract 1. We have 27 values on the left of the median. Now we need to get to the middle of that. So what's in the middle of 27 values? 27 plus 1 divided by 2. So 14th value from the start. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this 18 is going to be the lower quartile. And to find the upper quartile, similarly, we'll look at this 14th value starting from the end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is going to be the upper quartile. Okay, now we'll choose an appropriate scale and draw this box and whisker properly on the grid. So what scale could we take? We need to start with 5, go all the way till 70. So we could do 5. And then this could be 10, then 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. So yeah, that would fit. So properly mark all the values on the x-axis and um, label the x-axis, which would be distance in kilometers. Yeah, so distance in kilometers. Let me finish marking the x-axis. Okay, so that's done. Now we're going to mark 5 here, then 18, then 25, then 50, and finally 70. Now join these. I don't know why won't it let me make a proper linear line. Okay, pretend that's linear. Okay, next part is an outlier is defined as any data value which is more than 1.5 times the interquartile range above the upper quartile or more than 1.5 times the interquartile range below the lower quartile. Show that there is no outlier. Okay, so outlier is considered to be an extremely big data value as compared to all the other data values. And what defines as extremely big? It needs to be 1.5 times the interquartile range. Let me calculate the interquartile range of our data. Interquartile range is upper quartile minus lower quartile. So 50 minus 18, which is going to be 32. Okay, so what is 1.5 times 32? That is 48. So an outlier is something, some value which is 1.5 times the interquartile range, which is 48. 48 above the upper quartile. What was our upper quartile? 50. So if we do 50 plus 48, we're getting 98. So do we have any data values above 98? No, we don't. And then outlier is also something which is 1.5 times the interquartile range below the lower quartile. So what was our lower quartile? 18. Subtract 48 from it. That gives us negative 30. We don't have any value which is less than negative 30. So that means since we don't have any value greater than 98, we don't have an positive outlier, and since we don't have any data value less than negative 30, we don't have a negative outlier either. So you write since all data values are between 98 and minus 30, outlier does not exist.